Okay, this is Geometry Section 5.6, Notes 38, Inequalities in two triangles. Yesterday was just one triangle. Today is two triangles. So make sure you do your name, date, and class period right here, please. And your essential question is, how do you know how to list the side lengths in order from longest to shortest in a triangle? You should know that from yesterday. All right, we have two theorems here. It says Theorem 39 is the hinge theorem. And in this explanation, it says two sides of one triangle are congruent to two sides of another triangle. So it's like almost side angle side scenario here. But it's not quite side angle side. But it's like you have VW is congruent to RZ right here. And VX is congruent to RT, is shown in the picture. And then it says, and the included angle of the first one is larger than the included angle of the second triangle. So the 88 is larger than the 35. What that means is that the third side of the first triangle, in other words, this side here, WX, will be longer than the third side of the second one. So WX will be longer than ST. So here in the blank, I'm going to insert W or ST. I can get my pen to work. There it is. Okay. So right here, I'm going to put ST, and in the blank was longer. And it is the actual word instead of what I did yesterday. Okay. On theorem 40 is the converse, so it's going the opposite direction. So you still have to have two sides of the triangle being congruent to the other one, but this time they give you the third length. And here it says, okay, if AB is longer than DE, which you can see here, one has a 12 and one has a 9, then that means its corresponding angles, which if I look here, 12 goes down to the C angle and the 9 goes down to the F angle. That means C is got to be greater than the angle F. So over here in our blank, the first is longer than the third side of the second, then the included angle for the first is larger than the included angle of the second. So in the blank, we're going to write the word larger. All right, on example 1, it says that given that AD is congruent to BC, which you can see that right here on the picture with the little congruent marks that it has right there and over here on this side. So it has two sides are congruent. It says, how does angle 1 compare to angle 2? So we're looking at angle 1 is part of D down here, and angle 2 is part of the B. So I'm going to say, you know, is 1 bigger than 2 or is 2 bigger than 1? And the way to know that is looking at the sides that are directly opposite. Do realize that this still follows the hinge theorem because it says AD is congruent to BC, and then we also know that right here in the center, DB is congruent to itself because it's reflexive. So we'd still have side angle side taking place, but this is actually the converse because they give us the side measurements of 34. So I'm looking at the angles in relation to the 34 and the 33 down here. So knowing that information, what can we say about angle 1 in relation to angle 2? Okay, so is angle 1 bigger than angle 2, or is angle 2 bigger than angle 1? So if I'm looking at this, because of the 34, that means angle 1 is greater than angle 2. And if they said to explain, this is by the converse theorem, which was the converse of the hinge. And the number was just above, so I believe that was for 40. Okay. On number 2, it says a car leaves a mall. There's little car A. Leaves a mall, heads due north for 5 miles, and then turns due west for 3 miles. So it goes straight up and then turns left. Car B is leaving the same exact mall and then heads south for 5 miles, turns 80 degrees towards the east for 3 miles. So it turned 83, and here's car B. Their question is which car is farthest from the mall? So notice that they both traveled 5 miles in opposite directions. One went due north, one went due south. So the 5 miles, those sides are congruent. Then one went west 3 miles and one went east 3 miles. So those are another sides that are congruent. So I need to know something about the included angle here. Now the 90 is on the outside of the angle, so I need to know the interior angle. So 180 minus 90 tells me that that inside angle is 90 degrees. Okay? Down here on the bottom, the exterior angle is 80. So if I do 180 minus 80, that tells me that interior angle right here is 100 degrees. Knowing that information, what can I say about the distance from A to the mall and B to the mall? Which car is farthest? Well, if I use my hinge theorem, since the A car is across from the 90, this one is the smaller distance because the B car had 100 degrees, so this makes this one the longer, the larger, longer, or one of those words. Okay. So this distance is longer. Therefore, the farthest car would be car B. All right. If we turn the page, we have number 3 at the top, and it says if the measure of angle ADB, this angle here is greater than the angle of CBD, CDB, then this angle, which one is longer? So if the left side of D is the bigger angle, then that means the side AB is longer. Okay, that one's pretty easy. On problem 4, this goes back to our problem that we had with the cars. So we have the same scenario taking place. I don't know if I can draw it. You guys, oops, that's kind of crazy. And then it kind of does. Whew, okay, so here's car A, and this was 5 miles. This was 3 miles. This represented our mall. And this was, oh, here was car B. This was 5 miles, and this one was 3 miles. Okay. All right. In this scenario, it says, all right, so suppose we have a car C. It leaves the mall and goes 5 miles due west. All right, so it's going 5 miles. Here's the addition. 5 miles west. Okay. And then it turns 85 degrees towards the south. Okay. So that means it turns and goes this way. This angle out here is 85 degrees, and it goes 3 miles. Write the cars in order from the closest to the mall to the farthest from the mall. Okay, so that means this distance here on the end is where car C is located. Now, from before, we said this angle up here at the top was 90, and down here on the bottom for the B car, we said this was 100. So we need to find out what this angle is. So if I do 180 minus 85, it tells me that angle is 95. Okay, so which one is closest to the mall? If I'm looking like closest, that means I want the shortest distance, which is the shortest degree. So if I'm looking at my values, I have a 90, a 95, and a 100. The closest one is A. Okay. Then the next one would be the 95, which would be car C. And then the last car would be car D. Okay. So it's a pretty easy lesson. On the summary, it says to list the side lengths of the triangle from longest to shortest, what must first you know? So using this example you had above, this is just going backwards. If you're going from the longest to the shortest, what must you know?